Thank you for being here today. I am Francisco. I am the head of data at Mojang Studios. And today we're going to talk about Minecraft. Hopefully you're ready. This is the best place to be at GDC right now, so you're not missing out. Hopefully this will be a really enjoyable session for all of you guys. So over the next few minutes and over the next hour or so, we're going to talk about Minecraft players at the center of the universe of big data. And we have a lot of content prepared for you guys. This is a little bit of a casual session, but if you have questions, hopefully we can carve out some time at the very end for questions. If you have cell phones, if you can just put them on no ring, that'll be super helpful. And let's get going. All right, so today we're going to talk about a few things. I'm going to give you an update of who I am, what I've been up to for the past number of years. And then the best part, we're going to talk a lot about Minecraft. What is Minecraft, the scale of Minecraft, and a few other things. And then how we use data to represent Minecraft players at scale. Some of the techniques that we use, the technologies that we use to capture big data, and also to make that data into insights. We're going to talk a lot about our modern data ecosystem and how we've been modernizing our ecosystem. We're a 15-year-old game, right? How do we modernize it over time? And then talk a little bit about advanced use cases and the future, what we believe is the future of data-driven insights. So a little bit about me. I am the head of data. My name is Francisco at Mojang Studios. I joined the organization in 2020. Before I joined Mojang, I was at Electronic Arts. I managed the analytics efforts for several of their sports titles. I was in Vancouver. I see a lot of familiar faces, people based off in Vancouver, BC, big gaming community. I was managing analytics for FIFA, NHL, and UFC. I'm going to tell you a little bit about my team at Mojang. I manage 4 different teams. We have a data analytics team. And can I see a raise of hands? How many of you guys are analysts or data scientists or power users of data? Very cool. So quite the representation here. So I'm happy that you're here because we're going to talk a lot about your world. We have also a data engineering team that manages just data technology. And these are technologists managing data pipelines. We have an analytics environment team. This is basically the layer between analytics and data engineering, right? That builds data structures. Really talented team. And then we also have an AI and ML small team that focuses mostly on prediction and recommendation. And we're going to talk a lot about prediction as we get into kind of the deeper use cases. So before we start talking about data, about how we leverage data to drive player insights, I want to talk about Minecraft because that's what we're here for. And I'm going to play a very, very quick video. So hopefully you guys can remember if you're a gamer, what Minecraft feels like. If you are not playing Minecraft today, hopefully this will entice you to start playing. Yeah, can I get a, let's go Minecraft. I've always wanted to do that at GDC, so thank you. All right, so let's talk a little bit more about Minecraft and in particular focus on Minecraft scale. Minecraft, if you have been living under a rock for the past 15 years, it is the original sandbox open world or one of the original sandbox open world video games. And what does that mean? It means that there's no predetermined storyline, right? There's no beginning, there's no end. Players are basically free to do whatever they want to do in the game. Whether they want to craft, they want to survive, they want to engage with friends, battle a mob, you name it. It's the original metaverse, right? Minecraft is also available in most endpoints where players engage with video games. We're operating today, our main Bedrock Minecraft version is operating 22 different endpoints. So players can use their consoles, their mobile phones, their PCs, you name it. But for those of you in data, you can imagine the task at hand, normalizing data coming from different endpoints, 22 of them, different generations, partnering with app stores, with Google, Apple, Sony, Nintendo, you name it. But it makes for a great player experience. Minecraft is also massively diverse and global. One of my favorite stories is we did a geolocation study a few years ago, and we ended up finding out that there's activity in Antarctica. And we're wondering what in the world could be going on in Antarctica. Is it a research base, a team of scientists that are just playing with Minecraft during the free time? There's probably something going on there. We saw activity in the Vatican. But at one point or another, our PR team actually approved us to use Talking Point. Minecraft is played in every single country in the world, and that is super cool. And last but not least, very importantly, Minecraft is the best-selling game of all time. Last year, we crossed this milestone. 300 million players have purchased Minecraft in the past 15 years. That is a huge milestone. There isn't any other title that has achieved that milestone. And in order to celebrate, we released some data. You have it on the screen. A few fun things that happen in Minecraft on a single day. This is one of our data scientists going into the ecosystem and taking a snapshot. What is it that's happening in the ecosystem? 6.7 million diamonds, 15 million skeletons slayed, for example. So we partner very closely with our marketing teams and our PR teams to talk data. So now I'm going to talk a little bit about the context of data science and insights team at Minecraft. We believe that we operate in the intersection of art and science. If you think about Minecraft as a product, it is highly creative, right? Minecraft is beautiful, and you have on your screen in the wallpaper, one of the scenes, right? Where there's a lot of creative, there's a lot of art, and we interact with a lot of creative folks in the organization. But there's also a lot of science, not just on Minecraft, but also in understanding what players are doing in the ecosystem. So a good example here is our endpoint strategy. Being across 22 different endpoints, reaching every single corner of the world, that's a technical issue. There's a lot of science behind that, right? But looking at the scenery, looking at cherry blossoms, the mobs, the end game, the nether portal, those are all creative decisions. And our team, the player and data insights team, operates right in that intersection, the intersection of art and science. So now I'm going to pivot a little and talk a little bit about how we represent players at scale. Remember that data point, over 300 million copies sold. You can probably go online and figure out very quickly that we're one of the titles with the most monthly active users in the world. And representing players at scale requires quite a bit of sophistication on the data side. I'm going to take you back to 2019. Again, so for some of you who are power users of data in a studio, are data scientists or analysts, you probably experienced or have experienced throughout your career a version of this. A few years ago, we were capturing a lot of data as a title. We had the scale, we had the footprint, and we had the telemetry, but the data was landing and we didn't know what to do with it because it was too big, right? How many of you can relate to that? Where you just maybe a studio here and there are capturing too much data? It's also very fragmented. It was very fragmented back in the day. And what this means here is that you have marketing and commerce, and you have services teams, you have many client teams all producing data. And they would land it in a MySQL database in some corner in the studio somewhere. And that made it really hard to access that data and that information. And last but not least, data scientists, analysts, power users of data spent a ton of time coding. They spent a lot of time trying to write SQL or other types of data language so that they could write ETL to basically create a snapshot that converge a couple of data sources together. So I'm going to jump into an example around one observation, one analysis that we delivered as a team at one point or another around that time, 2019 and 2020, and how this sort of analysis could have resulted in a lot of difficult and probably the wrong decisions for the studio. So back then, there's a question that came from our creative team to one of our data scientists, highly talented data scientists. Should we be investing in friends features? Is Minecraft a social ecosystem? So this super smart data scientist Remember, they're operating in this very highly fragmented data ecosystem where data was very difficult to wrangle and to access. They take a snapshot of the average number of friends in the Minecraft ecosystem, and they come back with this histogram. And if I ask anybody here to read that histogram, you probably can't read much into it, right? Other than the fact that this is a massively left-skewed graph that basically tells you that most Minecraft players only have one friend. And when we looked at this data, we were shocked, right? We were like, what in the world could be going on? Because that's totally counter to our own experience as gamers, totally counter to what we experience on YouTube and social media, and even the primary research feedback that we get from players. They're telling us, hey, I have a lot of friends in Minecraft. So yeah, that made it feel like Alex and Steve just kind of had each other, and it was a very lonely ecosystem. And that prompted a big discussion around like, hey, are we actually looking at the right metric? Are we looking at the problem through the right lens? And a very basic question, a very important question that is very often overlooked in studios. Sometimes we're moving so fast that we're just asking questions very, very quickly without really thinking about which lens, how we're gonna look into the prism and understand whether we're actually asking and looking for the right data. So in this instance, we actually looked at probably the wrong data. We were looking at friends list, and we actually looked at the fact that maybe most players were only adding one friend to their friends list. It doesn't mean that the ecosystem was broken or that players were not engaging with each other. It just meant that our friends list feature itself needed a little bit of love and work. But I'm gonna jump into a really fun exercise that helped us get to that point of understanding that the ecosystem is actually social. How many of you guys remember this concept? 6 degrees to Kevin Bacon. You guys remember it? Raise your hand. See it? Yeah. So this was really popular right in the 2000s, and I remember in college, we actually had a class dedicated to this problem. The basic concept here is if you start looking at your friends' connections and social connections, family, so on and so forth, we're all more or less connected to Kevin Bacon by up to 6 degrees of separation. And I would love if you guys can run this exercise by yourselves after this session and start thinking about your network of friends, or maybe people here in the organization. I bet you that Phil Spencer and some people that are highly networked actually maybe know somebody who knows Kevin Bacon. Or if I start mapping out my own network of friends and family, I can think about friends who live in California, for example, and maybe someone drives an Uber and maybe one of them dropped off a pizza for Kevin Bacon. Yeah, there's a connection. This was a very interesting concept back then, the beginnings of network graphs and network theory. And we tried to adapt that in a similar study, 6 degrees of Alex and Steve. And this was fairly groundbreaking because we had to make a lot of changes to the data ecosystem to be able to get to this sort of analysis. So here's the concept. On the screen, you have a beautiful graph. Can anybody take a guess, just a wild guess? What does that look like? What does it resemble? What is it? You have to shout because I can't hear. A universe, stars, right? Yeah? Very cool, yeah. Minecraft super users, great answer. Yeah, so this is just a visualization of a random sampling of a network graph. And basically what we do here is we take a random sample, 40 players randomly, and then start following their connections. Similar to the study about 6 degrees to Kevin Bacon, you guys remember that? We try to do something similar to try to understand how players are connected to each other. And you don't have any legends on the screen, so you can imagine what the colors and the size of the bubbles mean. It could mean, the size could mean the type of, the amount of connections that a player has. The color could mean different things, like the platform. I'm not sure what that's joining. Like the platform, or it could mean something like the geography. But you can describe using player networks and player analysis a lot of what is happening in the ecosystem. In this specific example, what we ended up finding out is that 40 players connect to 300 players, and from there are a lot of what we call super social butterflies. and they are connecting players with each other and making the ecosystem a lot more fun for each other. And that's really cool. They're connected to 12,000 players. When you started mapping out the connections from those 12,000 players and onwards, if you keep going up to 6 degrees, you're probably connecting the entire globe. Anybody who's part of society is connected to Minecraft by 6 degrees of separation or less. That is really cool, isn't it? And you probably can map it out in your own games. So now, another concept here, this is an analogy, and I'm kind of old, but I used to participate in LAN parties. Raise your hand if you ever played in a LAN party in college, or maybe you were walking around San Francisco or wherever you're from, and you would see a flyer, right? And then you would carry your PC, and it was super heavy, and you kind of try to show off, and that's when we started putting lights on PCs and big fans and stuff, right? But the old LAN party, there was always that one person. There was one person that connected everybody with each other. They took it upon themselves to plan the LAN party and buy pizza for everybody else, and invite their friends and pass flyers around. So that has evolved, right? We don't see a lot of LAN parties. Maybe you see hackathons here and there, but that is all virtual now. And our modern version of a LAN party and what we see happening in the Minecraft ecosystem is happening a lot through social media, in a combination of social media and personal servers. Can I see a raise of hands? How many of you are familiar with Minecraft Realms, the product? So a few of you. That's an offering. Minecraft Realms are personal servers. These are servers that live on the cloud, where players can save their experiences, but also share invites and share links with friends and family, etc. But one of the things we see is that players are sharing links on social media, and these are not players that are like super popular on social media. They maybe have 5,000, 10,000 followers. These are not the Mr. Beasts of the world, but they're trying to build a following, and they're playing a big, important role in the ecosystem. They're making the game more fun for others. They spend a lot of time curating those experiences through user-generated content. They create mini games. They create themes, and that's really cool. If you ever have some time free, today or tomorrow, go on YouTube Shorts, go on TikTok or whatever, and just look for Minecraft, and you'll see this presence, this willing players that are sharing links with each other and making the ecosystem a little bit more fun with each other. So now, looking more at player connections, really, really important to consider how players are connected with each other. And this is another visualization of a separate study that also describes how Minecraft players are connecting with each other. And you guys remember the concept of the LAN party, right? The LAN party was local. You could only just like hang out with your friends in college and all network with each other with an Ethernet cord. Nowadays, in the world of Minecraft Realms or personal servers or cloud experiences, you can actually get players to connect with each other no matter where in the world they are. And one of the studies we did, this is at the city level. We mapped out the connections between cities across the world, and we saw some things that are really surprised us, but it actually make a ton of sense. You see all the cities, random sampling of a few cities of where Minecraft activity is happening. Just a note there, you probably don't see activity in China, mostly because we actually have a completely different product in China, Minecraft China. You see some low activity in places like Africa and others. The reason why is because of internet connectivity. That doesn't mean that Minecraft players, people in Africa are not engaging with Minecraft, for example. It just means that they're not necessarily engaging with multiplayer across the world. But some really cool stuff that we saw from this exercise is you can see a lot of connections. The yellow connections are what we are calling super connectors. In Minecraft data, you can probably already tell we use the word super to describe big things a lot. And the yellow lines actually tell us that there's like a super connections between few cities. The western side of the United States with the western, with Chile and Argentina, for example. And Mexico. That makes a lot of sense, right? There's a language commonality there. Eastern side of Brazil, connected to Western Europe, possibly Portugal. There's another language commonality there. Lots of connections between US cities and European cities. So that's really cool, right? All of a sudden we know that there are connections that aren't necessarily just happening locally. They're happening all over the world. And imagine building the experiences where there's such diversity, right? We're now talking about experiences that include players from all over the world based on themes and trends and things that they're excited about. So I thought that was a really cool exercise. What enables a more nuanced view of a player? We wouldn't be able to do this with old school technology. Like I mentioned earlier, 4 years ago or 5 years ago, we were still in a world where we were just parsing out a single day of data, and it made it really difficult for us to understand this sort of nuance. Well, fast forward, our data ecosystem has been modernized, and these are some of the components. Every decision that we make from a player standpoint is made with players in mind. So a player-centric data ecosystem. Basically, we pay careful attention to what types of data we're going to capture, but also being mindful that the data that we capture needs to really be in the service of improving the player experience. There's a lot of data out there anywhere in the world, right? There's social media, there's a lot of behavioral, there's a lot of commerce, marketing, you name it. And sometimes our data ecosystems can get really cluttered. The razor that we use here is, can this data set actually help us improve the player experience? Flexible technology. We're going to talk a lot about our data ecosystem and the technology that we use. But one of the best decisions that we've made over the past number of years is detaching the storage of data from the compute of data. For those of you who are data engineers, data scientists, you probably understand this concept really well. We have a great technology partner with Azure Databricks, and I'm going to give you just a little bit more visibility into our data architecture. And last but not least, you remember our data scientists, our analysts were spending a ton of time writing code just to get data. This is probably happening with some of your power users today, right? They're just telling you, hey, I have to write code for 4 or 5 hours a day just to get a simple snapshot of what happened yesterday. That doesn't scale because we've been able to create a ton of efficiencies by modernizing our ecosystem. We can now focus on product insights first, prediction, that's a very powerful application of big data, as well as artificial intelligence and machine learning. And we're not talking just LLMs. We'll give you some examples around LLMs, but the machine learning space is super powerful and very important in gaming, and we'll talk a little bit about that. So now, every time that I present something about data, I get asked for VCF flows. Hey, where's your VCF flow? Show me your data architecture. So here it is, a very simplified version of our data architecture. And it has 3 components. If you're a data engineer, if you're a data scientist, and you're at a big studio, you probably can think about 20 different hops that data goes through, right? But we try to simplify as much as possible, reducing the number of hops, reducing the number of technologies that are involved. I'll start from the top down. We use Azure technology, obviously. We're a Microsoft-owned company. So our storage technology is actually fairly flexible. We use Azure Blob and also Data Lake. And we capture a ton of different sources of data. So we have data coming from game product, for example, telemetry. We capture data from different services, social media, operations, you name it. So then, you guys remember I talked about the fact that maybe in the studios data can be fragmented. We virtualize most of that data using what we call our virtual source of truth. And this is a very important component of our ecosystem. In the world today, we're using Apache Hive, but that's really old school. We are hoping to modernize this using our technology partners' catalog. We leverage Azure Databricks for the processing of data. And we are in the process of exploring a move towards the Unity catalog, which just will help us accelerate massively. But virtual source of truth concept is really important, and we're going to double click into that because that can actually make a huge difference in accelerating the consumption of data in a studio. And last but not least, very importantly, how we process data and how we consume data. Your data scientists, your analysts are probably telling you all of the time, hey, I have to go to 5 or 6 different endpoints just to get a snapshot of data. We merge everything into a unified data environment, a single source of truth in Azure Databricks. And that actually has created quite a bit of efficiency because now we have all of our data scientists, all of our analysts in a single environment. They're sharing notebooks. They're not sending code over email or whatever they were doing in the past. So huge accelerator. If you're interested in double clicking into this ecosystem, We worked on a use case, on a business case with our technology partners, Azure Databricks. You can go into databricks.com and go customers and find our Mojang use case, and it will give you a lot more detail into some of the changes that we made to be able to get here to 3 components in a data ecosystem. So now I'm going to jump into this concept of virtual source of truth. It sounds simple, but it can be a huge accelerator. A virtual source of truth basically means that we go into one system, a single system, to capture as much, to download or create data snapshots coming from different sources. We have product, commerce, social, support, game health, quality, marketing, you name it. Virtual source of truth is that normalization layer that today in our world lives in Apache Hive, but that's a technology component. In addition to technology, we also need experts. So we've been hiring for folks that are subject matter experts in some of these different capacities: product, commerce, social, marketing, so on and so forth. The two combined, technology and subject matter expertise, are what we refer to as the data insights ecosystem. So really important. You can have the best technology in the world, you can have the best huge investment on a very modern data ecosystem. If it's not consumed by experts, then it's not going to be meaningful. And the other way around, you can hire rocket scientists, you can hire the most expensive software engineer in the world. If they don't have the right technology, they're not going to produce the output and results that you're expecting. So really powerful combination, people and technology. So now I'm going to jump into a really cool application. How do we use this data insights ecosystem? When we are talking about people and technology, okay, so what does that mean? I'm pretty happy with my SQL database, or I'm pretty happy with like whatever data store you use today to get data or insights for your product. I'm going to show you a few use cases and where we've been able to accelerate quite dramatically. Raise your hand if you read National Geographic, or if you watch a National Geographic documentary at one point or another. Pretty much everybody, maybe 80% of you guys. There's a really cool, powerful, very powerful concept. This is from 2011. They actually created a composite face of the most likely human being back in 2011. So the most likely human being, if you take a random sample of humans enough times around the world, they're back in 2011 probably looked a little bit like that image. There are a lot of characteristics that they described back then, right? So average income, geography, you name it. So those are average characteristics of a human. And what struck me as really cool is that National Geographic was able to take some very complex scientific studies and facts and put them together into a narrative that made sense for all of us. And that's really cool. This was on TV, documentaries, and magazines. The other thing that National Geographic does really well is they will actually find examples of average or expected outcomes out in the wild and take a camera crew and document that. And I think that's really cool. Like in this example, they have penguins, right? And they'll send out a camera crew to Antarctica or wherever penguins are, and they'll say, now we expect the penguin to do this and that and protect their offspring and all this fun stuff, right? And you're wondering, like, how in the world did they find out like this, that they translate into the science into an actual video? They probably spend a lot of hours just watching penguins do nothing until like the science actually becomes true. But the power of storytelling is really cool, right? We try to apply something very similar in our world, where we try to create narratives. We try to create stories based on what the science of the data science is telling us. And this is satire. No, Minecraft Steve has not been in National Geographic. This is a poor representation using AI. But we do have a pretty cool study, which is what we call the life of the most likely player. For a while, we were calling it life of the average player. And my team would get up in arms and say, that's impossible. You cannot have an average player. You can have a most likely player. So I think that's the right language. But anyways, what we try to do here, and one of the things that we're able to do now with technology and subject matter experts, is actually look at the player experience from a horizontal point of view. Whereas in the past, maybe we were looking at vertical snapshots. Do you guys remember the example early on around like, oh, what's the average number of friends in the ecosystem? And we got some SQL query and it was like 1. Well, that's not true, right? But now our effort is really trying to understand what players are going to experience through their entire life cycle playing Minecraft, from the beginning to the very, very end of their experience. Hopefully there's no end, but sometimes, people churn from games and it happens, and we try to explain that. But I'm going to tell you a little bit about what we found through that study, and hopefully this feels very familiar because you see it a lot in games. All right, so the first stage is player onboarding. You probably all have seen that there is a lot of risk of churning players early on in a player experience. You're trying to wonder what is happening through an onboarding process. Are players understanding how to get into a world? Are players understanding how to find the game modes that they are looking for? And are players able to find their friends? So this day one experience is very, very important. After you've kind of gone through that process of getting a player into the game, there's a lot of risk. Then the question becomes, how do I get them to find the fun, right? Early life. What are some of within the first few weeks of engagement, or even days in the case of mobile games, what are some of the experiences that we should be putting in front of players, depending on what that player's activities, that could potentially optimize their possibility or their potential to stick around for long, for hopefully forever, but churn happens. And then mastering the game, another really important stage. One of the things that we found that kind of differentiates early life from mastering the game is that in early life, it's all about getting players to find the right experiences, whether that is starting to engage a little bit more with friends, find marketplace content in Minecraft Marketplace. Whereas when it comes to mastering a game, you actually start finding out that we create a lot of problems for players in the sense of technical issues, bugs. The context really matters in this stage. For example, when players are more likely to start hitting connectivity issues or latency, online latency issues, it's when they're getting really good at the game, right? They start to push the boundaries of their own hardware. And last but not least, creating a lifetime relationship. And this is a little bit more open-ended, right? After a player has been engaging with 5 or 6 years in an ecosystem, then what's next? And we pay very careful consideration into the ideation of gameplay updates, for example. Have we updated certain parts of the game more frequently than others? We use clustering and other types of ways of describing what players are experiencing and how they are experiencing the ecosystem to try to give some guidance to our creative folks and understand what could potentially be a good gameplay update. It's no secret that Minecraft updates the game every year, every so often. We recently launched a small gameplay beat back in December. We actually think a lot about what the right mix of experiences should be so that players can actually come back to the ecosystem and we can continue to create this lifetime relationship. So this study, the life of the most likely player, has allowed us to really look at a player experience from a horizontal point of view. So now I'm going to jump into a few additional use cases around this data insights ecosystem. We're going to talk about the intersection of social media and player support. And can anybody take a guess? What's the commonality? What's the common denominator between social media posts and player support tickets? Is there a common denominator? You can take a guess from a data standpoint. Yeah. Yeah, people are providing that feedback online. They're submitting a form or they're providing that information. What else? Yeah, new users could potentially be going into social media, player support to try to ask questions. Yeah. What's that? Thumbs up, thumbs down, where people are dissatisfied? Yeah, absolutely. The more toxic elements here and there or more frustrated could potentially be a common denominator. But also, and this is actually the simplest answer, we get text data. We get a lot of text data from social media and player support. So here's a couple of applications. This is where we start using applied LLMs, AI at scale. And it's actually really cool, not for the reasons that you probably think kind of out of the box, which is like it's really cool to use AI, but it also actually helps us represent players in places that we had never imagined we could represent them. And I'm going to give you a couple of examples of where that is happening. Last year, we released Minecraft Legends. That was a very successful game for out of the door. Had a ton of installs, particularly in Minecraft, Microsoft Game Pass, in Xbox Game Pass. But before we released Legends, we released a gameplay trailer on YouTube and other social media platforms. And one of the things we did was we created an application leveraging, at that point in time, the Azure implementations of GPT-3 or GPT 3.5. And we passed through a lot of information, a lot of comments that were coming to us through both social media and YouTube video comments, for example, about what players were expecting, what they were speculating the game was going to be based on the gameplay trailer. So very, very early, we were able to call out and work with the gameplay team and say, hey, here's what the players are expecting based on what you're showing on a gameplay trailer, and this is what the game actually offers. So if you think about the application there, your social media team can react very quickly, your game spokespeople can react very quickly, you can start thinking about patches, so on and so forth, right? To kind of, if there is a divide, kind of bridge that. The other place where we were getting a ton of feedback as well is through the app stores. So at that point in time, we were also, after we released the game, we're also able to tap into a lot of commentary through social media and others. This is about a year and a half ago. That was when LLMs were starting to become a little bit more normal, and it was starting to become a little easier to pass through data. We use cognitive services. We use the Azure implementation of OpenAI algorithms for LLMs. Very useful. And the most practical application here is on translation. It's not just about understanding feedback at scale and being able to dissect it very, very quickly. It's also being able to translate from languages that nobody in the studio speaks. Another big application, and this is just leveraging traditional natural language processing, Minecraft.net. If you go into help.minecraft.net, one of the things that we do is we capture a lot of feedback, right? This is voluntary feedback. But one of the things that we've actually realized is that the feedback, when players self-select the issues that they're facing, is biased. And it's biased for the most obvious reason. Players want to submit and create a help desk ticket as quickly as possible. So when we create different forms, we actually introduce a lot of friction for players to actually be able to tell us what in the world is going on with their game when the game's not starting. And if you think about it from a player standpoint, right? Minecraft is not responding, and maybe you were signed out of Xbox Live or whatever is happening, and you're trying to get help, you're going to try to follow the path of least friction to actually get to submit a support ticket. So what ends up happening is that we end up getting a ton of false positives, where players are telling us, hey, Minecraft is down, when the reality is it's a completely separate issue that may be just impacting a couple of players. But we actually use algorithms, and we use data to help us really truly understand what players are experiencing. On the right-hand side of the screen, you have one scenario, 2 hours of help desk support data, where we're seeing a lot of help desk come through using natural language processing, very simple application, a word cloud, access. Okay, maybe we should think about what could be impacting player access very quickly. The more advanced application using clustering algorithms, where we actually work with different teams, Minecraft Realms, Minecraft Marketplace, and others, and bring data to those teams, telling them how many tickets we think are impacting players and how they can potentially take steps to improve the player experience. So very easy application, low-hanging fruit of the data data insights ecosystem, providing data that is very, very quickly accessible and can result in important insights for the studio. Now I'm going to jump into one of my favorite applications, the intersection of product and commerce. How many of you are familiar with recommendation engines? So see a raise of hands, quite a few of you. So I've been part of several AI conferences over the past number of months. And one of the things that really strikes me is that recommendation is a big data problem that not only gaming is interested in, every single industry, right? And when we think about who pioneer recommendations, you will normally think about Amazon, right? You'll think about Netflix, TV, streaming. They have a lot of content, lots of big catalogs, so they have to recommend. But gaming historically has been at the forefront of recommendation. We just don't always think about that. And I'm going to give you a couple of examples of how players are experiencing recommendation in-game. Here's the coolest thing about all of this. Our data scientists can go into our single source of truth through Azure Databricks, craft an algorithm on their free time, and actually push the results of the algorithm to the game directly. And they can start an A/B test in Minecraft Marketplace in less than 2 hours. So I wake up in the morning, it's 7:30, and I have an epiphany. Hey, we should incorporate player ratings into the winning algorithm. I'll have access to the winning algorithm because it's a notebook that's already stored in Databricks. I will make the changes, push it into an A/B test, work on just setting up traffic, and voila, I will know if my idea was successful or not. So this rapid experimentation, this integration between the game, the data ecosystem, and scorecarding is really powerful. This is how players are experiencing. We have two flavors of recommendation in Minecraft Marketplace. Today we have a basket of goods recommendations through recommended for you rows. If you're a Minecraft player, go into Minecraft Marketplace and you'll see it and tell me, does it actually make meaningful recommendations for you? And that's actually a personalized engine. And then on the bottom we have related items. That's more of a basket of goods type of recommender. But what's really cool about this is, again, everything is all integrated, right, into this data insights ecosystem. We're also able to push communications to players. There's a couple of different ways where data scientists can trigger communications directly to players through our marketing team and others. Push notifications outside of the game, but also in-game communications with patch notifications, as well as email. All of that is integrated, lives in harmony. So if we have a churn model, for example, we could potentially use different types of communication. It all lives in the same place. So shout out to the Minecraft data science team. We have a data scientist, super talented data scientist, Miguel Gonzalez Fierro. He was the leader for this GitHub recommender repository. This was recently transitioned to the Linux Foundation. So I mentioned earlier that you don't always think about gaming being at the forefront of recommendations. 20,000 stars on GitHub, hugely popular recommendation repository. Now everybody is on the train of LLMs, so there's a lot of repos in GitHub that are more popular in AI today because of LLMs. But any data scientist or any analyst that's interested in recommendations has probably stumbled into this recommender repo. We have probably 40 or 50 different algorithms because it's all open source. You can actually look at all of the code that we use to make recommendations inside Minecraft today. You can take that code and actually use it for your own game. And you can inspect it. Most of what we're doing through algorithms is really just making data processing faster and making inferencing a lot smarter. But check it out. Really, really cool. I think a big milestone for the data scientists in the team to be able to collaborate and transition over to the Linux Foundation and make this all open source. A few additional use cases. We also use the product insights or data insights ecosystem for product insights. Here's a really easy example. You probably try to understand where you're introducing friction in your game. Sankey diagrams. We basically just look at telemetry from the start to the end of a session and try to understand how are players getting to the game. This helps us in a few different places. Minecraft is a game that has been around for 15 years. A lot of the decisions around menus and how to get into the game, so on and so forth, they just happen from a creative standpoint, and maybe there's no rhyme or reason. But how do we get players to find the fun quicker? Reducing the number of hops and steps, and Sankey visualizations are very easy for us to produce. We actually use the visualization capabilities of our Azure Databricks environment completely out of the box there. Text and language, I already talked a little bit about text and language applications. So we're experimenting with LLMs to be able to translate at scale. But this is a very important application, obviously. I mentioned Minecraft operates in every single country in the world today. And we want to make sure that every single person in the world is represented. And we have a ton of bias, mostly because Minecraft employees speak two languages, right? English and Swedish. but what about the rest of the world? And this is where artificial intelligence, LLMs, and natural language processing will be huge accelerators. And then prediction and forecasting. This is a very important function. Try to forecast how players are going to be interacting with the game. Seasonality, you probably have very strong, robust forecasting functions in your own studios, but we use the data insights ecosystem for some of these applications. So now, last but not least, also talking about experimentation. We mentioned how we have already merged some of our experimentation capabilities into the data insights ecosystem, highly integrated with Minecraft Marketplace today, but we're also looking at web. We're also looking at a few other places to accelerate on experimentation. So I'm going to move into kind of the last few portions of the conversation. I'm going to talk a little bit more abstractly about the things that we have learned over the past number of years when creating and trying to accelerate the way that we use data insights to make player experiences a little bit better, but also give you some perspective of what we think is coming next. First of all, biggest realization over the past number of years is you have to continuously look ahead. The world, especially in the world of data insights, is continuously disrupting itself. We have a lot of trends, and I'll double click into some of those trends that are happening today, where natural language is really going to become really important in our world. And I will give you some perspective on where I think things are headed. But I will also love to hear your perspective in the next few minutes. So looking ahead, harmonizing. And when I mean harmonizing, it's not just about technologies. We live in a software company inside Microsoft where technology can be implemented in many different ways, right? But having a technology answer for a people challenge is not the right path always. So when I say harmonize the data insights ecosystem, it means, yes, figure out the technology part, but most importantly, figure out the people part, because people interacting with technology is really the formula for unlocking advanced insights use cases. And last but not least, iteration. One of the biggest realizations being in the gaming industry for the past 20 years or so is that we treat data products as like this super convoluted software releases. And a lot of teams, when I talk to folks at different studios, big studios that are going to release a new game, they literally start from scratch. Every time that they're going to release a new game, they like literally migrate to a new data source, or somebody, the VP of data just decided that we're moving from this technology to the other technology, and it'll take 2 years to get to it. And I'm like, how in the world do you have 2 years when games don't even survive for 2 years, right? So one of the things that we've really taken upon ourselves to try to do is our roadmaps are very nimble, and we're just changing one component at a time. It's basically evergreen iteration, trying and failing. We're always doing a POC. 100% of the time, we're always POCing. We have our technology partners here in the group, in the room. We're always trying new things. And now, talk a little bit about where we're headed. So I put myself in the shoes of a data scientist that's just coming into the industry, and what are they going to experience? A power user. I think we're a few months away, not years, from experiencing true no-code insights. And what does that mean? We're already seeing a ton of Copilot applications, right, that are very good at dealing with business information. But we're starting to see some really interesting applications of the GitHub Copilot equivalent for big data. And in particular, we're trying out the AI assistant inside our Databricks environment today. I just have to come up with an idea. I have to explain what the idea is using natural language. Like, hey, join these two tables together and count the number of sessions. And the AI assistant will do it. So I think we're getting to a point where no code is actually going to be a reality, but we're still going to be required to think like data or think about data structures. But that also creates a little bit of a divergence in the way that we think about data structures. So the volume of knowledge will explode. As we are able to access data sets through natural language, as our data ecosystems become more efficient, it's not a matter of if, it's a matter of when. You'll also see an explosion of of insights around that sometimes may be conflicting insights. So very important to try to understand how do you understand what to pay attention to. And historically, this wasn't a problem, right? Back in the day, you had one source of data and you analyzed that source of data. And that's what resulted in a lot of decisions. And we call that the street light effect, right? Just because we have a light in a small section of a street, then we focus on that section of the street and completely overlooked the rest of the street. But what we're gonna see today is that you're gonna actually see lights that flash in many, many different directions and through different lenses. So how do you understand paying attention what's important? And last but not least, the first and the last mile of data insights are become the most important. I truly believe that some of the activities that we're engaged in today are going to evolve. In the world today, we're still writing a lot of hard-coded ETL, for example, to create data structures, right? That will evolve. Instead of creating the schemas for data, we're actually going to tag data. And we're going to use natural language to be able to access and create meaningful relationships over time. So that's kind of the first mile, right, of the creation of meaningful data sets. And the last mile that's also going to be really important is this whole concept around using storytelling to convey very complex messaging to creatives and power users, decision makers in a studio. With that, I believe that we have a few minutes left. I will just end with a thought. The end is the beginning. That's one of my favorite thoughts. Hopefully you've learned something through this session, but we have a few minutes to cover any questions or comments. We'd love to hear from you. Yeah. Let me try to give you a mic, but it might not work. We'll see.
Testing?
Yeah, it worked.
It's such a big company as Microsoft and Mojang. It's the overall decision process for unifying those very different data formats when creating your data ecosystem.
Yeah, really good question. The question is, it's a big company, right? So how do we deal with decision making when making decisions around what technologies and how to converge? So the nice thing about Mojang is living in the world of Microsoft, we actually have quite a bit of autonomy when it comes to making decisions around which technologies to leverage. At the same time, we also have a lot of dependencies on other teams, and in particular Azure teams, right? That can either be data producer or technology providers. But fortunately, in the world of gaming, Mojang makes most of the decisions when it comes to the technology stack. So if anything, our Azure partners have been huge accelerators. When we encounter situations where there's a little bit of a disconnect, like for example, the Azure team wants to use specific technology that may be really good for commercial use cases, but not so great for gaming in particular, we need time series, we need very quick iteration, right? Having a conversation about it. And so far, haven't hit any roadblocks when it comes to decision making. Fortunately, it is a place where we have to talk a lot to a lot of different people, but studios have quite a bit of autonomy, which is kind of cool. I think there's one there, and then we'll come here.
You mentioned separating the compute and the storage to scale better and such. What do you use to reduce your costs when you start having explosions of data?
Yeah, that's a really good question. There's a couple of ways of doing this. Thank you. We have a budget, and like every other studio in the world, we're probably fairly constrained. And one of the things that we pay attention to is what data we're capturing. Because I think there's generally a practice where you capture a lot of data just to figure out when we can potentially use it. So being very critical around whether the data is actually going to serve a player purpose. The second piece is, fortunately, separating the compute from storage allows us to go into low-cost storage solutions. Whereas in the past, the world of relational databases, you kind of had both processing and data storage in the same place, and that's super expensive. Nowadays, we're literally storing data in the cheapest place possible in Azure Blob, especially if it's not mission critical data. and we use the processing layer. What's really cool about the processing layer that we're using through Databricks today is that the clusters can turn on and off. In the past, we actually had virtual machines doing a lot of the processing, and they were always on. So that actually allowed us to get to a pretty important reduction in like-for-like cost. For other reasons, we're using the data ecosystem more these days, then the mix of costs has shifted. But those are a couple of really important best practices. And then freezing data. So we have like a cold ocean every once in a while for data that could potentially be used because of legal reasons or whatever that is not always stored. It takes a little time to like thaw that data. But thinking about the strategy of like going to low cost storage wherever possible, low latency storage for mission critical, like in-memory type of storage, and then being critical around how and when you actually need to use processing. I hope that helps.
I'm just curious because there are so many versions of the game. From a data standpoint, is like one single team overseeing all the versions, and considering that sometimes their experience is not necessarily the same, who defines what needs to be analyzed?
That's a really, really good question. And that becomes a little bit of a people question as well, right? So from a data strategy, one team, one data engineering team, and one analytics ecosystem team handles all games. And all of our games have aligned into a single tech stack and telemetry SDK. And that just creates benefits from like really understanding the network effects from multiple titles. So that's just a data strategy. And I think that really takes alignment from different game producers around the franchise to get to that, at least a tech stack commonality wherever possible. We follow a central but embedded model when it comes to analytics. So even if the tech stack is somewhat normalized, we actually have analysts that are embedded with the game teams. And they will also give guidance to the data engineering team and the ecosystem environment team around niche data sources. Like if there's a game that's doing something very specific that doesn't apply to others, we try to build data sources in a way that's kind of future-proof. Like a good example would be, think about user-generated content. Not all of the games have it. We'll build the data structures in a way that's forward-looking, assuming that other games will eventually start using user-generated content. And that kind of goes back to the principle of like, look ahead wherever possible. What's wild sometimes in gaming is that we're not allowed to look ahead because we're moving so fast. So getting in front of that train sooner rather than later. Yeah. Any other questions? There's a question over there. All right.
Hi, yeah. So you told us that you looked at your most likely player and what they get up to during the game. Do you also do any work on player segmentation? And if so, what's your approach? What sort of drivers are you looking for when you're segmenting your players?
Yeah, that's a great question. So the most likely player was really an exercise around trying to describe averages so that we could start thinking about points of friction and points of opportunity and actually convey that in a very simple way. But we do have a segmentation framework in place using k-means clustering. We also run this in the same data ecosystem. The parameters that we select for that k-means clustering are really behavioral as well as profile type of variables like platform, medium of consumption, session days, the things that we use to describe players in generally. But one of the coolest things we've also done is we use our telemetry events are descriptive of the activities that our players are engaging with. So like we have an event that says, I broke a block. And another event is, I traveled to a new biome. And we use natural language to help us create those clusters so that we don't have to like supervise the k-means. We're learning from our partners at Rare that there's a few additional new applications that we want to try out. But right now we have probably around 10 different clusters, mostly using k-means. We refresh that once a week. All right, we'll start here and then go over there.
Hi, great
Hey.
presentation, thanks.
Thank you.
Quick question. Your stack seems to have changed, as you mentioned, from 2019 to now. What made you decide to keep Hive as the source of truth?
Yeah, I ask myself that every single day. But yeah, honestly, I think it's a combination of factors. The newer alternatives are fairly recent. Like, for example, the Databricks Unity catalog, which is kind of what we're exploring, has access control and governance baked in and all of that fun stuff. We had already invested so heavily in the Hive Meta Store that we already have a functioning catalog. So it's a little bit of a legacy question there. And for honestly, like, it's not the technology, it really is the processes that we're working through towards getting to that point of migration. The cool thing about having kind of a legacy meta store is that we have years and years and years of historical data, and that helps us with forecasting and just accessing what has happened for the past 5-6 years. Sorry, yeah, there's one more question here. We'll come back.
I'm just curious, with like modded Minecraft being a very significant part of the community, are there any telemetries built into capturing, gameplay activities within that realm? And I guess as an add-on, is there like a significant player behavioral difference between Java players and Bedrock, which is like the uniform platform across, all platforms? So
Yeah, great question. I can tell you're a Minecraft player. Yeah, so Java is a little bit of a different world. Java has an opt-in framework for telemetry, and also you can download your telemetry, which is kind of cool. But we definitely see that modded Java is very, very popular, hugely popular. We do a lot of inference using the launcher, the Minecraft launcher, to tell us, hey, this person went in the direction of unmodded vanilla Minecraft or the direction of modded Minecraft. Because if you think about the launcher, that's where you have a lot of like your big mods like Forge and others. So we rely a little bit more on inference in the Java ecosystem because the data is just a little different. But again, that's kind of part of the normalization. Getting the data in all data in a single source of truth really helps us be able to deal with kind of those disparities. Understanding Java and Launcher, they're kind of different products but tied together. And Launcher gives us a lot of visibility into what Java players are doing. The other thing we do is Bedrock has a lot of user-generated content now. Believe it or not, it's really cool. And we do inferences. Like when a player is doing modded Bedrock, we try to use some of those learnings as analogies for Java. Great question. All right. Oh, there's one more. Sorry, last one.
I was really interested in what you had to say about the last mile and the telling of stories using the data. Can you tell us any more about that? And in particular, how do you control for any kind of personal bias that involved in the people crafting the insights into stories? How do you control for bias creeping in and making sure that those stories are accurate, and faithful to the data?
Yeah, that's a really good question. And bias is one thing that we've talked a lot to the studio about, because everybody in the studio is a gamer and they feel very strongly about the direction we should be going. And we have people that have been around for 15 years or so. So one of the things we actually did, probably the best thing we've done, is actually make people aware that bias is a risk. And we actually did training sessions specifically on bias. The two big concepts that we tried to reiterate with the studio was the big risk of the streetlight effect. When you have a dashboard that's very easily to access, you're going to read so much into that dashboard, but totally ignore the really hard to get data. And then the risk of cherry picking. Hey, I like this because it says that my product is profitable, so I'm just going to amplify it. So the line of first defense, it sounds soft, but it's actually our data scientists, because they're highly trained in this risk of bias. And they can recommend tests. So we actually are doing a lot of tests. If you're paying attention to Minecraft, these days we're probably running 4 or 5 different experiments at all times. Starting today, for example, we're testing different setups in the main screen. 2 years in the making, and I'm actually really excited about it. And that really is a debate that has been going on for 2 years. And we're like, hey, proof is in the pudding. Let's test it out. And we have A/B testing capabilities now that hopefully allow us to get to the point where, hey, this is actually significant from a statistical standpoint. Thank you. All right. Well, thank you guys. It's really been super fun. Hopefully we'll see you guys soon. Cheers.